Hello, my name's Jane Hawkins and I'm a maths teacher at a secondary comprehensive school in Devon, and I'm so pleased to be here sharing my thoughts with you around when I'm planning to teach ratio. This video is in 4 parts. First of all, I'll consider the big idea when planning to teach ratio, some of the necessary prerequisites, the key teaching aspects, and why I think teaching ratio is important. So first of all, what do students need to know? Well, really, the big idea is that I want my students to have an understanding that any two numbers can be connected by a single multiplier. I also want them to understand that proportional relationships are multiplicative rather than additive. I want them to understand that numbers can be made smaller as well as larger by multiplication, and that all proportional relationships share the same underlying mathematical structure, even though they may be presented in different contexts. So what things typically go wrong? Well, lots of my students had at least some of these misconceptions. Students might think that they can add a constant to each part and that doesn't affect the proportionality when we know it does. Some students might think that fractions and ratios and percentages are all separate bits of maths and that they're not connected by the same underlying mathematical structure. And students might think that proportional multipliers can only be integer. So I might address some of these misconceptions with some well-chosen examples or questions that don't fit within their misconception. If you've seen Catherine's video on multiplicative reasoning, she talks about these lengths of wood and scaling, this notion of scaling, and I might choose some examples similar to those with a non-integer multiplier. So I've got an example there. I also, when I was starting to plan to teach ratio, I thought about my representations from the very beginning, so I was using a really coherent set of representations and also really careful about the language that I use so it's consistent throughout the whole unit. I think some of the misconceptions that arise when pupils are thinking about ratio is this notion of fairness mixed up with ratio. Also, I want students to be able to move from this sense that things can be a proportion of something else, and also they can be in proportion with each other. So these are some of the statements from the DFE programme of study. So ratio and proportion is a new strand in Year 6 from the Key Stage 2 programme of study. So all of our students will have had some experience of ratio and proportion, but that doesn't necessarily mean that they're secure in their understanding. So some of the prerequisite knowledge and skills I want my students to have is I want them to have a really good grasp and fluency with their multiplication tables, and we're seeing an increasing sort of fluency with those tables coming through in our students now. I want them to be really fluent with a number line, and that to be a representation that they're really familiar with using. And I want my students to be able to share into equal parts, not just sharing, but specifically into equal parts. And these are some of the representations that I might choose when I'm starting to introduce some of these ideas or check these prerequisite skills. So the top left is about sharing it to equal parts and making sure that that's a representation that they're familiar with. On the top right is a set of number lines that we can have integers on number lines, we can have non-integers on number lines, including fractions and decimals, and that also we can have blank number lines, and that we can fill in a lot of information if we're familiar with the structure of a number line. The bottom left is a factor-factor product model, which I think is used quite commonly in primary maths education, and being able to use that as a representation from primary through into Key Stage 3 gives a really coherent sort of learning and understanding journey. So next is thinking about the key teaching aspects. And when I was thinking about the unit of ratio that I was about to teach, I really thought carefully about the key message I wanted my students to leave that unit with an understanding of, some of the language I was going to use, and some of the skills I wanted them to be able to do. I also wanted to think really carefully about the representations I was going to choose so that they were consistent and coherent throughout the unit, some key questions I was going to ask, and the key connections where this understanding of ratio would lead them in the future. So first of all, the key message. I'm really careful that my pupils don't confuse not being able to find a multiplier with not being able to do ratio. So in Key Stage 3, the outcome is that students should be taught that a relationship between two two quantities can be expressed as a ratio. And the NCETM PD materials takes this a little bit further, and that any two numbers can be connected by a multiplier, and also this set of connections between fractions and ratios and percentages, and they're all actually just representations of multiplicative relationships. Some of the key language I think about using, got some key vocabulary there. I'm increasingly careful about expecting my students to answer in full sentences, with including explaining their reasoning. And I'm really trying to avoid language around proportional quick tricks. So these triangles, equation triangles, which I know are really common in secondary school, but trying to move away from them and move away from rule following, so that this is based on understanding. So the key skills that I want my students to be able to understand, I've taken these from the outcomes, the Key Stage 3 programme of study. And although I think it's true that there are not particularly quick wins in education, the representation that I'm going to share with you today that I've used across my whole ratio and proportion unit has really supported my students in being able to make connections between the different topics that are labelled, but actually which are connected by the same underlying mathematical structure. So some of the skills from that are to be able to use ratio notation, and to be able to divide a quantity into two parts. There are lots of other skills, but I want those skills to be based on understanding. So those are the key skills I want my students to be able to do. There is a significant difference between skills and understanding, and I want my students to have these skills and be able to do these fluently, but also based on an understanding they have of the underlying mathematical structure. So here are some sort of pick and mix type activities, lots and lots of great resources out there for supporting planning to teach ratio. But actually, increasingly, I'm trying to move away from these kind of pick and mix examples and choose instead sets of questions which are thinking carefully about what it is that we are varying, and in varying one part, drawing attention to the underlying mathematical structure. So this thing, thinking about variation and how we include variation in questions, so that we are always referring back to drawing attention to that mathematical structure. In these tasks, I think there's lots of having to switch between different times tables and switch between different skills. So this is the representation that I've chosen to use to connect all of those different topics that are actually still an understanding of multiplicative and proportional relationships. And this is a ratio table, and I introduced it to my students as a representation I wanted them to be really fluent with and be able to use really flexibly. It's just a representation, but because it can be used in a variety of contexts, I think it really supports students in making those connections between different topics, which are all connected by the same mathematical structure. So, for example, a question such as, there are two numbers which are in the ratio 3 to 7, so again, towards that idea of in proportion with each other, and one of the other numbers is 42. What other possibilities are there for the other number? So getting students to start to explore that relationship both between the 3 and the 7, but also between the 3 and the 42 and the 7 and the 42. So this is using then that representation to support us in answering some fairly standard questions. So here's a recipe type question, and some of my students were getting mixed up and muddled and doing things the wrong way around, but actually being able to translate the information in the question into a ratio table really helped them in finding the correct bit of missing information. So finding that relationship, that scaling relationship of multiplying by 2, and then being able to use that to support their understanding and find the missing bit of information. Keeping it organised and keeping it very structured and using this representation to translate what they know. And then this can be extended, so if they're having to find lots of different proportional relationships, that actually the ratio table can be used anywhere across the recipe question, but we just need to think about that multiplier being changed depending on what we're relating to. So this is the key representation I want to focus on, and a ratio table comes from a double number line, and being able to compare and contrast the double number line to the ratio table is really key in them understanding. I don't want to water down the double number line, but I want to make very clear that this ratio table is only ever multiplicative. And if you are looking for more information or other examples of how ratio tables and double number lines can be used effectively, then the Using Representations at Key Stage 3 guidance from the NCTM is really, really useful. I read through it before I planned my unit, and it really helped me make decisions as to which representations I was going to choose. So the ratio table is connected to the double number line in this way, and I think this is a really useful image to share with students if they are familiar with a number line, and in particular a dual number line, and scaling up. So we can see where the parts of each number have come from, where the 1 and the 4, how the 1 and the 4 are related, but also how the 1 and the 3 are related and how the 3 and the 12 are related. So making connections between the dual number line and the ratio table, but I'm specifically focusing on using a ratio table in this video. So again, here's a fairly standard question, and I think it is important to be able to compare and contrast different representations. So I want my students to be familiar with lots of different representations, and that actually you should get the same answer however you do the question, however you choose to represent it, whatever method you choose, you should get the same answer if you have this understanding of proportionality and things in proportion with one another. So this is just representing the question in 4 different ways, and then we might make and compare and contrast the representations to see which is most useful for the question that we're choosing to use. So this is a task I did with my students just as a starter, and they were thinking about finding the missing bits of information. And then also when we got on to the 3rd and 4th ones, thinking about how many different possibilities of numbers there were to fit into those boxes. And the multiplier and the multiplicative relationship depends on what number we choose as to how tricky or how complicated it is. So lots of my students in the 4th box along chose 5 and 7, so the multipliers were nice and straightforward, nice and integer. But actually we had quite a good chat about that number in the top right hand box can be anything. It could be 8.2, and there would still be a single multiplier that would get us from 8.2 to 35, and therefore be able to find the 4th bit of information, 4th bit of missing information. And so that was a really rich discussion that we had around the fact that any 2 numbers can be connected by a single multiplier, even if the multiplier doesn't end up being a nice integer or even a nice terminating decimal. And then the 5th box was just about the endless possibilities, and we had billions and trillions and lots and lots and lots of different suggestions in there, really to let their imagination run wild and to embed their understanding that it's about any 2 numbers being connected by a multiplier. So then we moved on to starting to translate some fairly standard ratio questions into our ratio tables, and knowing which bits of information went where, how to represent the questions in a ratio table, and then being able to use the ratio tables, which they were now becoming more fluent with, to find a multiplier and then find the missing information. So these are some fairly standard ratio questions which we could translate into ratio tables to help us find out which bit of information was missing and the multiplier that we needed to use. Again, some fairly standard ratio questions. I didn't do it, but I wondered afterwards if a nice activity might have been to write some questions with the same number in, write lots of different questions with the same number in, but where a different part of the ratio table was missing, and see if they could match the question to the ratio table. So I haven't done that, but I might try that next time I teach ratio. So then we started moving on to thinking about using ratio tables in contexts which are not labelled as ratio, but actually are connected by this same underlying proportional mathematical structure. So there's a maps and scaling question, there's increasing by a percentage and converting between units, all of which can be represented. And this was really a light bulb moment for my students, because it meant that what they were spending time learning and becoming fluent with and becoming familiar with this representation and how to use it and how to translate questions into a format, a representation that they understood, how actually it unlocked lots of different topics within maths, but connected them all to this same underlying mathematical structure. So these are still some Key Stage 3 kind of topics, but then we actually extended their understanding, and these are some Key Stage 4 examples and how ratio tables can still be used. These aren't ratio questions, but we could apply what we understood about them and their underlying mathematical structure, and then therefore we could use a representation that we were familiar with. So it was quite an important moment for my students to understand that it was worth our while spending time getting to understand this structure and getting to understand this representation, because it unlocked lots of different parts of maths for them and it really supported them in making connections. So moving away from ratio tables a little bit, these are some questions I designed just to help myself get a bit of a better understanding of where my students were in their understanding of ratio and proportionality. But there are lots of nice questions. This one is from the NCETM secondary assessment materials. Again, some of my students instantly then put this information into a ratio table, and some of them started counting up in their twos and counting up in their fives and tens. And this was a really pivotal moment, because those students that had used the ratio table got there much more quickly. And the students who had spent time writing out their tables realised that actually this same representation was useful here. It was just a nice moment. Again, I use this in my class. This is from the Mathematical Prompts for Deeper Thinking. There are some really, really excellent PowerPoints that go along with these prompts. Well worth taking a look. And so some of my students had a go at some of these questions, and one of my students said, I don't know if I did it right, but I did it ratioly. So she was immediately thinking about making those connections, and it had come at the end of a topic of ratio, so it wasn't a massive surprise that, it doesn't, I'm not sure it counts as problem solving when it's a problem at the end of a topic that you've been doing, but she used what she understood and used what she knew about ratio and proportion, and that helped her make connections and answer this question. And obviously this can be extended. The trigonometric relationships are proportional, and the Mastery Professional Development materials for Key Stage 3 on multiplicative reasoning explore this a bit further. This is a video I really liked. I used this at the start of my unit on ratio, and it really highlighted some of the misconceptions that my students had, and it was a great place to bounce off from what they currently understood, and it was in quite a light context. And Catherine mentioned also in her proportional reasoning video about the mixing lemonade from Enrich, which is another really nice resource which I've used with my students. So if you are looking for some more information or want to understand ratio tables, then the proportional reasoning departmental workshop is where I first learnt about ratio tables, and it goes into quite a lot of detail about how they can be used and how they can be used from some quite basic maths in multiplication tables right up through lots of different contexts of maths. So if you want to do a bit more reading around ratio tables, that's a good place to go. Some other places I would go for designing questions on ratio or supporting me in my planning for teaching ratio are the Don Stewart website, the Medium website, and also Open Middle is another nice place to look for ratio prompts for designing my own questions. And the PD materials does similarly. It hasn't got a bank of questions, but it's a nice place to go for a bit of inspiration when I'm designing my own questions. Links to all of these, I think, should be in the supporting document that's available alongside this video. So I've been thinking about ratio a lot, and how a ratio table can support us in making connections. And I think that all of these topics, if I was given a question with anyone in any one of these topics, I could translate that into a ratio table and be able to find the missing bit of information. And I've since shared this with my students, and it's really highlighted for them how being familiar and understanding this structure of proportional relationships and multiplicative relationships and ratio will support them in understanding lots of different areas of maths. And it really became a really valuable learning experience that they were really invested in, because they could see how valuable it was going to be for what they were doing currently, but also where it would lead them throughout the rest of Key Stage 3 and also into their Key Stage 4 curriculum. So these are some of the parts of the Key Stage 4 curriculum that I think are also based on that same mathematical structure. So I hope this video has been useful, and that you find teaching ratio as exciting and interesting as I have. Thanks.